Okay, and we're live again. Hello again, students. Today we're going over lesson 14. I know we did some of this in class, but just to make sure we don't get behind, I am going to record this video for you so you can have a reference. Today's lesson is choosing units of measurements. First things first. We're going to cross out that word choosing. And we're going to replace it with converting. There's no such thing as choosing units of measurement. Okay. Converting. Typically, even if you're taking an exam, especially once you get to the elite, they're not going to ask you to choose a unit of measurement. They're going to tell you what to convert to. At the most, you might just be asked which unit of measurement is the most convenient to operate in. And usually the answer is going to be the largest unit of measurement that will have a smaller number to work with. Okay? Our objective, obviously, is converting. I hope that you are pretty good with converting according to how class went today. We need some extra assistance or maybe just a little refresher on how to convert. So I will briefly run back through the warm-up for today. This was your warm-up. We're just converting to an equivalent unit of measurement. For number 1, I did it for you. It's 6 minutes, and we're converting 6 minutes to seconds. I already have the answer up there, but I'm about to work it out. When you are converting, take your given your given value with the units attached to it, it's minutes, and raise it over 1. You're just putting it in fraction form. I hope you also know how to multiply fractions. If you do not, you will struggle. I hope you know how to simplify fractions. If you do not, you will struggle. So we have 6 minutes. We're going to put it over 1. We're going from minutes to seconds. Just off the top of my head, I know there's 60 seconds in 1 minute. When you are converting in expanded form, which should be every time, write the unit of measurement that you're trying to get to at the top of the fraction. So that's your numerator. Your denominator will be the unit of measurement that you're converting from so that it can cancel out on the bottom. All right, so we're going to seconds. So we want to put that 60-second conversion on top and 1 minute on the bottom. Okay? Off the top of my head, I know that 6 times 6 is 36. Therefore, 6 times 60 will be 360 seconds. 60 seconds. This minute conversion will cancel out. Don't worry about it. That is how you convert. Set it up like that every single time. You do have to write it down. I notice in class, a lot of y'all are trying to do mental math, but you're struggling with just putting it on paper. Follow the same format. Okay? Moving on. When choosing a unit of measurement, what do we have to be considerate of? This is more so a question for you to think about, but I will give you at least 1 or 2 answers just so you can have a little track to follow. When choosing a unit of measurement, I would definitely be considerate of how small is the unit that I'm working with, and then how much larger do I need to make it in order to make it convenient to be able to solve and perform mathematics with. Like if I'm converting from seconds to minutes, I know I only have to do 1 conversion. But if I'm converting from seconds to years, let's say, I know I'm going to have to do at least 2 or 3 conversions. So I need to be aware of how to properly convert. Not only properly convert, but properly set it up and then multiply and possibly divide if you happen to have a denominator that's not 1. So you have to perform the conversions accurately and without mistake. Otherwise, you'll get the answer wrong. Moving along. For number 1, we did this a little bit in class, but I'm going to go back over it anyways. For For problems 1 through 3, choose a unit of measurement to use for each problem. Scratch out that word choose and write the word convert. We're not choosing, we are converting directly. 1 says, you wonder how long you can listen to your favorite music before you hear the same song twice. You have 1,000 songs and the average song length is 4 minutes. Would you want to display the time in minutes, hours, or days of music? How I set this up, we need the total amount of time that the music would have to play first before we can even convert anything. In order to get that, we're just going to multiply 1,000 songs. If each song is 4 minutes in total, that gives us 4,000 minutes. Cross out would. Would you want to replace that with convert? Okay, so we're going to convert to display the time in minutes, hours, or days of music. The idea is to convert up as much as you can in order to make it convenient for yourself to perform mathematics if you had to. Just off the top of my head, I know that we'll convert to days, because 4,000 minutes, that is a lot of minutes, and I know that that's more than the allotted amount of minutes in one day. So we're just going to set up this conversion, rewrite 4,000 minutes, put it over 1. We're just putting it in basic fraction form, times going up to hours. We know that there's 60 minutes in 1 hour. We're trying to get to 1 hour, so we're going to put 1 hour on top, 60 minutes on the bottom, so that it will cancel out. Okay, but we're not stopping at hours, we're getting to days. So then that raises the question, how many hours is in one day? There's 24 hours in one day. One day is where we're trying to get to, so we're going to put that on top. There's 24 hours in the day, so that's going on the bottom. All right. Just for the sake of being able to see this in a different form, I'm going to rewrite it up here at the top. We're going to put 4,000 over 60 times 24. That is your fraction, because 4,000 times 1 is still 4,000, and then 60 times 1 is still 60, and then we have to multiply that to 24. Now I'm just going to use my calculator a little bit, and I'm going to give you the decimal answer to that. For whatever odd reason, you guys' calculators are giving you answers in fraction form. Thankfully, we know how to divide, so we can get the proper answer, but it's better if it's in decimal form, because that's the answer that's likely to be on the leap. Okay? In decimal form, this answer rounded up is 2.78 days. Make sure you include your units. If you don't include your units, technically your answer is wrong, only because you didn't put the units on there. Don't forget it. Here's another question for you to think about. I'll let you marinate on this yourself. I'll just read it for you. Why do the measurement for problem 1 make more sense when using the units of measurement we converted to? If you want to, pause the video here. Just think about that to yourself and then come back. But I'm moving on. For number 2, you wonder about the weight of all the oranges used for commercial production in the United States in a year. Your research indicates that each box of oranges weighs 85 pounds. Underline that. Annotate. And about 92 million boxes of oranges, underline that. Make sure you annotate, were used for commercial production in 2017 and 2018. Every passage you get, make sure you annotate properly. You only need the necessary information. Make sure you scratch out would you want to and put convert. Okay, and it gives us ounces, pounds, and tons. And we're basically just trying to figure out which one would make more sense to convert to. I can tell you now they gave us 85 pounds to begin with, and it kind of doesn't really make sense to convert down to ounces because there's 16 ounces in 1 pound, but that'll make this number much larger. Now if this was a decimal number, let's say if it was 0.8 pounds and I needed to make this number a little larger for whatever odd reason, then we'll convert down. But otherwise we kind of want to convert up to a larger unit of measurement, which in this case would be tons. But first we have to get the total number of pounds. We're given 85 pounds. Include your unit of measurement. We're given 92 million boxes of oranges. 92 mil, and I'm just going to abbreviate that so I don't run out of space. Doing some quick math over here on my calculator so you don't have to do it. That gives us 7,820,000,000 pounds. And I'm going to just squeeze pounds in on the end. Now, in scientific notation, that gives you 7.82 times 10. Counting my decimal places, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 7.82 times 10 to the 9th power. Raise that over 1. Put it in fraction form. This is pounds. Remember to include your unit. That's going to be so important because when you're converting, if you're not writing the right units, you're going to mess up. Make it obvious for yourself so that you don't make mistakes. Now going from pounds to tons, there's 2,000 pounds in 1 ton. Ton is going to be our numerator because that's what we're trying to get to. We're going to put 2,000 pounds on the bottom so that those pounds can cancel out. All right, that'll leave us with tons, a value for tons. On the side somewhere, write 2,000 in scientific notation. I'm going to give it to you though. That is 2 times 10 to the 3rd power. Here's how you're going to do this. You're going to do 7.82 divided by 2. In my calculator, that will give us 3.91. Next, we're going to do 10 to the 9th power divided by 10 to the 3rd power. If you can remember when we were multiplying and dividing like bases, when we divide like bases, all we have to do is subtract the exponents from each other. So take the exponent from the numerator minus whatever the exponent for the denominator is. In this case, it's 9 and 3. 9 minus 3 is 6. So that gives us an answer of 3.91 times 10 to the 6 tons. Now, to be honest, that is still a very large number, mind you. It looks smaller because it's in scientific notation, but that's still a very large number. That's just something to be aware of. Here's another check for understanding. Maybe just let this marinate, but I'll read it for you. Is 3.91 times 10 to the 6 tons easier to understand than other choices? Why or why not? Just take a few seconds to marinate on that to yourself. When you're done, come back. For number 3, the seafloor spreads at a rate of approximately 10 centimeters per year. You collect data on the spread of the seafloor each week. Cross out yet again that would you want. Write convert. Convert to record the data in millimeters, centimeters, or meters. I can tell you now, we're going to go up 2 meters for the sake of convenience. A lot of times, the smaller the number, the easier to work with. Converting up 10 centimeters over 1. Converting that to meters. I know there's 100 centimeters in 1 meter. Since we're getting 2 meters, I'm going to put that on top. Put 100 centimeters on bottom so it can cancel out. That'll give us 10 meters over 100. Cross out 1 0 just to simplify that really quickly. That gives us 1 over 10 meters, i.e. 1/10. If I put that in decimal form, that's just 0.1 meters. Make sure when you're multiplying fractions that you go straight across. Just make a note somewhere that you are not cross multiplying. You go straight across. You multiply the numerators with the numerators, multiply the denominators with the denominators. Do not accidentally cross multiply. You will get it wrong every time. All right, moving on. Another probing question: for which problem or problems, if any, did you or could you have used the properties of exponents in your calculations? Why or why not? I will say for number 2, let me go back to it. For number 2, when we were dividing in scientific notation, we kind of used, in a way, maybe the power of a quotient, maybe, because technically this is a fraction. Or we could have used, obviously, a product of powers with like bases, but in this case it wouldn't be a product, it'll be a quotient of powers with like bases. Well, we were subtracting that 3 from the 9 and 10 to the 9 minus, divided by 10 to the 3rd. So power of a quotient would make sense for that. If it's any other ones that could have applied either to number 1, 2, or 3, just make note of that somewhere for yourself. Moving on. Converting units of measurement continued. And we only have a few more questions, so just bear with me. Mr. Jacobs just welcomed a baby into his family. Since birth, the baby has been alive for 1 million seconds. Mr. Jacobs has been alive for 1 billion seconds. How many seconds older is Mr. Jacobs than the baby? Now, typically when something says how many of something or how many times of something, that usually means to divide. But in this case, since they want to know how many seconds older is Mr. Jacob, we're actually going to subtract. This is subtraction. Underline how many seconds older. And then write subtract. Now the first thing you want to do is put this in scientific notation. Now you can easily just enter into your calculator 1 billion minus 1 million and then put that answer in scientific notation. But for the sake of demonstration, I'm going to go into scientific notation first. Now 1 billion in scientific notation is 1 times 10 to the power of 9. We're subtracting, so put that minus. 1 million in scientific notation is 1 times 10 to the power of 6. Now, another way that you can do this is to manipulate that 1 times 10 to the 6 and force it into being 1 times 10 to the 9, or probably 0.001 times 10 to the 9. And then perform subtraction, because then that'll turn your exponent into a 9. If we backed up the decimal point on this 1, because right now it's at 6, but if I backed it up 7, 8, 9, that'll give you 0.001 times 10 to the 9. And then you can subtract normally and then keep the same base. So you'll just be doing 1 minus 0.001 equals, and whatever that answer is, times 10 to the 9. But if you don't want to do all that work and you don't want to work that hard for it, you can just do 1 billion minus 1 million in your calculator and then put that answer in scientific notation. Now me, since I already set it up, I'm just going to take 0.001 away from 1, and that gives me 0.999 times 10 to the 9th power. But obviously I cannot leave it in this form because our A value can only be between 1 and 9.999. So I need to move this decimal over one more time. That'll give me 9.99 times 10 to the 8 seconds. That's how many more seconds older Mr. Jacobs is compared to the baby. Okay? Moving along. Here, take a second to pause and just let this marinate on your mind. Take a second to think on how long 9.99 times 10 to the 8 seconds is in another unit of measurement. Meaning, how many minutes might that be? Or how many hours? How many days might that be? Shoot, how many weeks? How many months? How many years might that be if we converted? And then ask yourself if we should convert to another unit of measurement, because 9.99 times 10 to the 8 is still a very large number in seconds. And if we do convert, what should we convert to? Take a second to marinate on that and then come right back. Here we're going to do our conversions. And for the sake of demonstration, we're actually going to convert to years, since we are dealing with not just seconds, but age. I'm assuming Mr. Jacobs is a grown man compared to this baby. So we're going to convert in years because we are working with age. And that's typically how we measure age. We don't say that I'm 10 trillion seconds old. We'll say, oh, I'm 23, or I'm 12, I'm 56 years old. So we had 9.99 times 10 to the 8 seconds. We need to get those seconds to years. And we have to go one by one, convert one by one. But instead of calculating it every single time, we're just going to plug it in and set it up. So from seconds to minutes, in 1 minute, going to put that on top. There's 60 seconds. Don't calculate yet. We're going to keep going. Going from minutes to hours. For 1 hour, it's 60 minutes. Going from hours to day. In 1 day, it's 24 hours. Now, in 1 day, even though there's 24 hours, it takes 7 days to make 1 week. So we're going to multiply that continually. Make sure you write them side by side. I'm just going to put it on the bottom because I'm running out of space. 1 week is 7 days. Now, typically 1 month is 4 weeks, usually. To go from 1 month higher, think about 1 year. Now we're at 1 year. Yes, you have to write all this down. It is 12 months. in 1 year. Now we're there. Now, as you can see, we'll be multiplying 9.99 times 10 to the 8 to 1 a bunch of times. So essentially, we don't have to do anything with that. But what you will do is put that number in your calculator in parentheses, 9.99 times 10 to the 8 in parentheses. Hit divide, and then open your parentheses again, and then write 60 times 60 times 24 times 7 times 4 times 12. Close your parentheses and then hit equal, and that will give you a value in years. So we're essentially just dividing a bunch of times, but we're shortening the process a little bit by multiplying our denominators together after we've already set it up as division in scientific notation. And I'm just going to plug that into my calculator for you so that you don't have to do so much work. I'm plugging in my division, opening my parentheses. I put in 60 times 60 times 24 times 7 times 4 times 12. If you're doing it along with me, fantastic. Hopefully you are, because if you are, then you would have gotten in decimal form 34.412. But I'm just going to round that down a little bit to 34.4 years. That's the answer. Take a second to digest that. Quick note to self though. If you wanted to, you could have converted from days, and we could have put in 365 days in 1 year, by the way. It could have skipped this conversion here. I want to show you the whole process, but we could have multiplied after that and put 1 year over 365. And we could have skipped this one too, possibly. But I want to show you the whole thing. But that'll also give you 2 or 3 less steps. So make sure that you're taking the most convenient route. I just have to show you all the options because that's my job. But you still would have got just about what and what in answers. The question is, what is the new difference in age? I would think that's obvious. Obviously, Mr. Jacob is a grown man, so he is several of years older than the baby. Okay. Then there's the question, is years an appropriate unit of measurement? I would say so, considering the fact this is a baby compared to a grown man. And to say seconds or days or hours or whatever it is a grand comparison in numbers compared to if I gave the number of years. Years is much smaller to work with. If you made a prediction though for the value of seconds, how accurate was that? Just take a second to think to yourself on that, as well as this question: why do the units of conversions matter? Why is it important? Take a few seconds, pause, marinate on that to yourself about 10 seconds, and then come back. There's another example here for two-way radio problem, but we're not going to do that. We're going to skip right past that for the sake of time. Once again, just marinate here on these 2 debrief questions. Is choosing an appropriate unit of measurement important, and why? I would hope that your answer is yes. It is important. The reason why it's important is for the sake of convenience in working in smaller numbers but larger units when you have to perform various mathematical operations. And then there's a question, does choosing a unit of measurement influence the comparison of two quantities, and how? I'm going to let you marinate on that one for yourself. Okay, moving on to the exit ticket. Now your exit ticket is only one question, but it's split up into two. You get 1 point for answering A right. You get another point for answering B right. Be ready to do some conversions. That's what we've been doing the whole time. Conversions. All right. But once again, when you see choose, cross that out. Cross out choose and just write the word convert. We're not choosing anything. We're converting directly. Also, make sure you are setting up your conversions accurately. And whatever you're converting to, that's what your numerator needs to be. What you're converting from is what your denominator needs to be, so that those units can cancel out and it will leave the remaining unit that you're actually looking for. Remember that you are not cross multiplying. So you're not multiplying diagonally. You are multiplying horizontally. So you're going straight across in your multiplication. Okay? If you have anything to divide after, we'll do that after the fact. Preferably leave your answer in decimal form or scientific notation. Turn in this exit ticket tomorrow. I'll take it then. If you don't finish for whatever reason, or if you happen to be absent, just make sure I get it by Friday. Okay? Your homework, in case you need a reminder. First of all, your practice is only a few questions. Number 1, 2, 3, 4, and 6 on the front page. Those are your practice questions. Number 8 and number 9 is your homework. That's only 2 questions, but they're a little lengthy. They require some extra solving. That's why you only have a couple. For number 9, you only have to do A and B. Make sure you show all of your steps and make sure you are restating your question. For number 8 and number 9, each question that you have to solve is 2 points apiece. So your homework is 6 points. So you get 1 point for solving correctly and having the right answer. You get another point for restating the question and giving me a sentence on it. Do not lose easy points by not restating the question. You basically just have to copy and paste what the question said and then insert the answer and put it in statement form and take it out of question form. Do not miss those easy points. Also, your remember section, which is number 10 through 15, I think. That is your extra credit as usual. If you do it, that's up to you. If you don't do it, that's fine too. I always encourage it just for the extra points, but it's not a mandate. With that being said, have a good day. And I may record lesson 15 after this. If I don't, it's just because I deemed it to not be necessary. But we'll see.